Mohammed Memdouh, and we are group 3. Today we are going to demo our project for this course, which is digital circuits. In this course we asked to design an lamp logic for stationary bicycle. The main idea of this project is when the driver of the bicycle start increasing the speed, the lamps will start lamping one by one until they reach 5 lamps. When they reach the 5 lamps, all the results will be don't care, which means it will not affect our project or our gates and circuit. And now my colleague Abdurrahman will start talking about truth table.
Hi everyone, my name is Abdurrahman. I'm going to talk about the truth table. As we learned in this course how to fill up the truth table, here we have 3 inputs and 5 outputs. As it is required from us in this project, first, when our 3 inputs are zeros, our outputs will be 0 always, which means all the lamps will be off when the speed starts increasing. The first lamp will be on, which means in our truth table C equals to 1, and when the speed keeps increasing, the second lamp will be on, while the first lamp will stay on. Since this speed is increasing, the lamps will start lightening one by one until the 5 lamps are on. That means we reached the maximum speed, and the lamps will keep on until the speed decreases again. The main idea that when the speed started increasing, the first one will light and the other lamps will light one by one until the 5 lamps are on. As we can see in the truth table, that's why we can see in this truth table there are 2 rows filled up by don't care, which means that when the 5 lamps are on, we don't care for the speed increase. And now my colleague Mohammed will start with the K-map.
Hello everybody, my name is Mohammed Shamsi. I will talk about the K-map. As we know, the main idea of the K-map is to simplify our circuit here, as we learned in this course how to simplify the K-map. First, we get our result from the truth table and put it as 5 K-map because we have 5 outputs. For each lamp, we created a K-map, and as we know that to simplify the K-map correctly, we need to group all the ones together to get the simplest equation that can help us to simplify our circuit. Here in the first one, we have 3 groups, the 1 and the X and the 1 also. And this equation A plus B plus C. In the L2, we have 2 groups. We group the 1 and the X and the 1 and the X in the 0, 1 and 11 and 10. And we have this equation A plus B. In L3, we group this and we have also this equation A plus B, A plus BC. In L4 we have 1 group and the equation is A. In L5 we have this equation AC. And this is for the phase 2. Now my colleague will explain the other phase.
Now I will start talking about the hardware. First, we simulated our hardware in phase 3 as a Tinkercad circuit. Here we can see the 5 lamps and this gate which is 74HC08 is our AND gate, and the 74HC32 is our OR gate. For the first lamp, it is connected to the output of this 2, which is directly connected to the switch 3, which is C, and this one, which is the result of C and B, as we can see, A and B, sorry. So if we end up with this equation, which is A plus B plus C. For the second lamp, which is A plus B, if we press the wire, we can see here that this is the output, which is coming from, actually this is the output, as we can see here, which is coming from this wire and this wire, which is A and B. Here, this wire and this wire, A and B, connected directly to the switch. And we have here the third lamp. If we press the wire, we can see here that the third lamp is output for this 2 wires, which is this wire is the, as we know that this is AND gate, so here we have A multiplied by B, so we have AB, and this is the output of it, connected directly to the input of the second gate, which is OR gate, and ORed with what, as we can see here, with A. As we can see here, the equation A plus BC. For the fourth lamp, which is the equation of the fourth lamp, as we got from the truth table, is A. So we connected directly to the first switch here, A. And for the last lamp, which is AC, lamp number 5, here lamp number 5, as we can see, it's the output of these 2 inputs, which is A and C. Now I'm going to simulate our circuit and check the result together. So first, if we start all of them 1 1 1, all the lights are open, and if we have 0 0 1, we have only lamp 1 is open, and if we have 0 1 1, we have the first 3 lamps are open. And here, in the case of 0 1 0, we have only 2 lamps open, lamp 1 and 2. And in the case which is 1 0 0, we have here the 4 lamps are open, lamp 1, lamp 2, lamp 3, lamp 4. And for the case which is 1 1 0, we have also the 4 lamps are open. For the case and the last case, which is 1 1, we already did it. And for the idle state, when they are zeros, all our lamps are 0. Now I'm going to show you our hardware connections and test it together. I will just join from my phone, transfer to this device.
المايك off.
I'm sorry. Thank you, Mohammed. Here, as you can see, this is our hardware connections, and this is our voltage source. Actually, any socket can deliver 5 volts, so it can be good for our circuit and not harmful for it. So now as we can see, we have 3 switches, and this is the 2 gates. Here we have the 5 lamps. Here the 5 lamps. When we start by the case of 001, so C is 1, which is the first case. This is our result. As we can see, only 1 lamp, which is lamp 1. For the second case, which is 010, we have 2 lamps, 1, which is lamp 1 and lamp 2. For the third case, which is 011, we have 3 lamps on, which is lamp 2, lamp 1, lamp 2, lamp 3. For this next case, which is 100, we have 4 lamps, lamp 1, lamp 2, lamp 3, lamp 4. For the next case, which is 101, we have the 5 lamps are on. And for the case which is 110, we have only 4 lamps on, which is lamp 1, 2, 3, and 4. For the last case, which is 111, we have also the 5 lamps are on. And I want to thank you, and I want to thank my colleagues Muhammad and Abdurrahman, for this demo. And I hope everything is clear for everyone. As you can see here, our circuit and our hardware. Thank you.